Okay, my phone is dying, but a quick little video on Doppler effect. I just want to give you some quick notes about sound before I talk about this. So, just so you know, pitch is associated with frequency, so a higher pitch of sound is associated with a higher frequency. In other words, a shorter wavelength. Volume is associated with amplitude, so a higher amplitude means louder sound. So anyway, Doppler effect is something you've probably experienced. When an ambulance whose siren is going off is coming towards you, you might notice that the pitch of the sound increases as it accelerates towards you. But we know that when a wave is generated, frequency remains the same. So why is it that you're hearing a higher pitch as that source of sound is approaching you? Well, what's happening is, it's not that the frequency of the siren is changing, but actually, as the ambulance accelerates towards you, those wave fronts are going to hit you faster. So you will perceive of a shorter wavelength and a higher frequency. So you can kind of see that in my diagram over here. It's putting out a uniform frequency of those waves, but as it's driving towards you, those wave fronts will hit you faster and faster, so you will perceive an increasingly smaller wavelength, lambda, which in turn results in a higher perceived frequency, given by the equation v equals f lambda. Speed of sound is a constant, so if the perceived wavelength decreases, the perceived frequency will increase. Well, when that ambulance passes you and accelerates away, it's going to start to take increasingly longer for the wave fronts to reach you, thereby increasing the perceived wavelength and decreasing the perceived frequency.